This topic today we are going to see is autotransformers, which appears in module 3 on transformers of E311 electrical drives and control for automation of KTU, Kerala Technological University. Now transformers, we know it is actually used to transfer power from one circuit to the other. We've seen the characteristics of the transformers. Now, what is special with this autotransformers? Now, autotransformers actually provide a variable AC output compared to a fixed output voltage to a primary fixed voltage excitation in the case of two-winding transformer. Compared to that, we get a variable output voltage. So that is the difference with the autotransformer. So we can say that the turns ratio is actually changing, or if you compare it with the two-winding transformer, the phenomenon that is taking place can be assumed as if it is its winding ratio is changing. So the basic function of an autotransformer, as any other transformer, is to provide a AC output from a AC supply. So the function, the difference in functions with two winding is that here there is a continuously variable output voltage. Now, how that is possible, we'll see how that variation in voltage is possible. As I mentioned, two winding, and this transformer has a single winding, as if it is, and just we are varying the tapping points so that we get a variable output voltage, keeping the supply voltage fixed. Now, what are the applications? Applications involve those cases where we require a variable AC voltage. And another name, by the way, of this transformer is variant. Often if you go to market, you can see that variant, it is mentioned as variant, a variable AC. So another name of autotransformer is variant. Now, the applications. So, as I mentioned, it is for places where we require a varying amount of voltage, AC voltage. So you have a fixed supply voltage, and then you convert or you get the desired voltage based on the position of the knob of that autotransformer. So that is a very simple way to use that. Now, second application is the starting of induction motors. So starting as any motor, you have studied DC motor. So in a similar way, in AC motors, while you start, there is the rotary is at rest. So that can create a lot of short circuit current through, current, and that current will be drawn from the supply that can damage the windings. So in order to limit that current, you have to limit the voltage, or you have to reduce the voltage. So that function can be obtained through application of autotransformers. So that is one of the major application. And another popular one is with the power system. So the transmission voltage is maybe 110, 210, so 220, like that you have seen. And when you want to shift it, change its magnitude, or to adjust the voltage levels to respond to various situations in the power system, you use autotransformers. So this is the basic function of this auto. So it's a very important device and performs the function of transformation. Now here we will see later when you analyze the circuit that there are two possible ways of power transfer from the supply to the load. So basically, even if you're using a two-winding transformer, the thing that's happening is a transfer of power from the supply to the load, and intermediately you have this device. So here also the auto transformer is the intermediate device which connects your load to the supply. So here one chief advantage of this auto transformer is the saving of copper. So you can see that in the case of a two-winding transformer, you have two separate windings, and they can handle the same amount of power. That then, I mean, based on the current requirement, the thickness of conductor, etc., as determined. And we'll see that in the case of auto transformer, there is actually saving in the copper. So it is the amount of copper that is required to make a transformer for a given kVA is less for auto transformer than with the two-winding transformer. So let us see the basic circuit and step down. You can actually put it two configurations, that is step up and step down. So step up I will draw here. I'm sorry, step down I will draw here, and we'll analyze that based on the circuit. So we have the supply side, so P1. So normally we will give notation like this. So this is actually the power flow diagram, and this is how the things happen. This is P2 will be putting like this. The significance is that the power flows from this direction. Here also this lower. So now we'll decide. We have, say, total N1 number of turns connected to the primary side, and N2 number of turns that is across the secondary. So here what you can see, you have current and I1 coming and I2 going out, both those indicating in the say V1, I1 the input power, V2, I2 the output power. Now the current through this N2 number of turns, which is a part of that N1 turn. So that is the major difference with the two-winding transformer. So two-winding transformer, you have this N1 and N2, iron core. There's two lines in the case. So this N1 and N2 are separated, whereas here you can see that this N1 and N2 are actually forming a part of the same continuous winding. So there is no separation, electrical separation. So here that is continuous. So this is N1 minus N2 number of turns here. So the current here is, so this current is, you can say it as I2 minus I1, because applying KCL you can find out that this is the magnitude. That is, if you take a node here, you take the sum and see that, so what is happening. So that is what, how you get this value. Now this is the supply side, power is coming from here and then getting it transferred to the side. Now you can see that this winding has two portions, one that is here and that is here. Now from here, there is conductively there is some transfer of power, and from this winding to this winding there is an induction. So even if that is what you call a continuous winding. It is wound on a core. You can see that there is an induction of what you call inductive effect, which may be helpful in transferring power inductively. So conductively and inductively, there is a transfer of power, and this power is actually given to the load. So from supply, these two means of power transfer is there in the autotransformer. So this is the function, or this is how your autotransformer works. Now, if it is in the step up mode, you will have a smaller winding over here, and you have a outer way. You have, outside you have a very large voltage. So there is this difference if it is a step up. I mean, here on the, if you think from this side, you have V1 here, I1 here, everything changes, the direction changes. And here on the outside, you have a very large voltage compared to this. But that voltage amount may not be that much quite large, maybe something which is very, very near to double or something like that. So beyond that, it is not so easy to get a stepping up phenomenon. So this is actually a step down configuration, and we will note down how this current and all these things. Now the comparison. How can we compare with the two winding transformer? So two winding, you have I1, I2, maybe say V1 and V2. It is driving load in a similar way. V2 is there. Now, how can we compare? The cost is the chief factor which actually goes into this analysis, isn't it? So, how can you relate the cost to the circuit? So, that is the question here. Obviously, the thickness of copper decides the price of the transformer to a great extent. So, we have to think in that way. So, how can we do that? So, in the case of ordinary transformer, two winding transformer, you have two current, that is I1 and I2, and two ampere turns. And this ampere turns, as we know, it determines the amount of this copper, because number of turns, then I2 will be indirectly related to the cross section, area cross section of the winding. So N1 into that will be, say, I1 will give the a proportional quantity. It will be proportional to the amount of copper that is there in the primary winding. So I'll write, say, N1 I1, and similarly N2 I2. Okay, so that is with the ordinary transformer, two winding transformer. Now with this transformer, with this configuration, you can see that this, there are two things. There are some portion called N1 minus N2. You can see that, and then N2 portion. So N1 minus N2, as you can see, it carries a current of I1, and N2 carries a current of I2 minus I1. Right. So these two are the cases. So say here you can plus it because it doesn't matter. Here also you can plus it. So these two are the quantities that are concerned when you analyze. So I'm just rubbing off the circuit, two circuits, and let's see the relationship. So you have this, finally you have these two